So I know originally yesterday that I said that I was going to show you guys adding and subtracting and multiplying rational expressions, but I decided against that because I wanted to make sure I really hit this adding and subtracting rational expressions. Believe it or not, for those of you planning on continuing to pre-calculus and even calculus, this is going to be a really important skill for you guys to be able to do. You know, this you definitely want to make sure that you understand. And of course, this is important for everyone because it's going to be, assessed and, graded and stuff like that. So, but especially for those of you that are planning on going on to pre-calculus and calculus, you will definitely want to know how to do this and be comfortable with it because you'll need to be able to do this manipulation. Okay, so what we're looking at today, like I said, is adding and subtracting rational expressions. Remember that rational expressions are simply expressions that can be written in the form p of x over q of x, where these are both polynomials. So it's basically just like a quotient of two polynomials. And yes, you could divide them, right? I mean, we know how to divide polynomials, right? Synthetic division, if the q of x is a binomial in the form like x minus k or x minus h, I guess you might say there. And then you'd have to use long division if q of x was not in that form. Okay, anyway, though, we won't worry about that for right now. To add rational expressions, well, remember to add rational numbers, so that's what we're going to start with here today, reviewing adding fractions, which are rational numbers, right? To add fractions, right, well, it's, like all the rules you ever learned about addition, you can only add like terms, right? So right here, this fraction right here is saying that we have 1/4, and we're going to add to it 5/4. So if you have 1/4 and you add 5 more fourths, how many total fourths do you have? Well, you now have 6/4, and that's your answer, right? You add the 1 and the 5, and that makes 6, and the denominator stays the same because it's kind of like your unit in some sense, 6/4, right? So this, of course, simplifies, though, so we can do that, and we'll say that's our final answer. But this is an acceptable answer, right? It's still correct, but typically you simplify those fractions, too. All right, now, when we go to add something like this, though, 1/4 plus 1/8, now we are adding two different things, right? Apples and oranges, or maybe like Gala apples versus like Red Delicious apples. They're the same, they're both numbers, but they are not the same kind of, they're not the exact same kind of number, right? This is 1/4, that is 1/8. And so we need to translate them so that they are the same kind of thing. Maybe even a different kind of apples wouldn't be a good idea. It's more like adding centimeters and inches. Centimeters and inches both measure distance, but centimeters and inches are in different units, so you need to convert one to the other to be able to combine it together. Same thing here. Okay, so what do we got to do? Well, hopefully you remember, right? Then you need to get a common denominator. Okay, yes, very good. I hope I heard you say that. Anyway, so what's our common denominator going to be here? Well, can we manipulate 4 to become 8? Or can we manipulate 8 to become 4? Or do we need to manipulate them both, right? So it turns out we can easily make 4 become 8, right? So we're going to take that 1/4 and we're going to multiply by 1. But not multiply by 1 like that. That's not very helpful because that just becomes 1/4 again. Instead, we'll multiply by 2/2. Now, why 2/2? Well, let's watch what happens here. 1/4 times 2/2. Well, to multiply fractions, you multiply across the top, multiply across the bottom, just like that. And so this becomes 2/8. And then we still have that plus 1/8 there that we're going to add in. And so now we took that 1/4, converted it to 2/8, okay? And now we can add these two things together. 2/8 plus 1/8 is 3/8. So that is equal to the 1/4 plus 1/8 then, right there. Okay, so what I did here with the 1/4 and multiplying it by 2/2, okay, it didn't change the value, right? I multiplied by 1. 1 does not change the value of something. And so then we end up with that 2/8, which I can add to the 1/8 then to get the 3/8. Okay, and so we didn't change the value of the 1/4. The problem was still the same thing. I just rewrote 1/4 in an equivalent way to be able to add them together. All right, same thing is true here for something like 1/4 and minus 4/5. Okay, but in this case, right, I can't easily multiply 4 by something to get 5, nor can I multiply 5 easily by something to get 4. So what do we do? Well, we have to come up with a common denominator, something that's going to be a number that we can kind of, multiply to with the 4 or the 5 and the 5. So we can think about multiples of 4, it goes 4, then 8, then 12, then 16, then 20, then 24, then 28, and then 32, and so on and so forth, right? And the multiples of 5 are 5, 10, 15, 20, 25, 30, so on and so forth. But you'll see here that the multiples of 4 and multiples of 5, we can get them both to be 20. And so that's what we're going to shoot for. That's going to be our least common denominator here. So with 1/4, to make that 20, we'll multiply the top and bottom by 5. And to make the fifths into 20ths, we'll multiply the 4/5 by 4 over 4. Again, in both cases, we're multiplying by 1, so we're not changing the value of this expression at all, but what we are doing is changing what it looks like so we can easily add them up. So 1/4 times 5/5 becomes just 5 over 20, and then 4/5 times 4/4, so 4 times 4 makes the 16 there, and 5 times 4 makes the 20. Okay, and so there's our answer. And now we have that nice common denominator so we can subtract our numerators. So 5 take away 16, and I guess I could write it like this, maybe, if that helps to see it. So we get negative 11, which doesn't simplify anymore. Okay, so that's what we're going to be doing today with our rational expressions. Remember yesterday, right, we were adding up rational expressions. Here's an example from like what we saw yesterday. All right, we already had a common denominator here, and so we can go ahead and add our numerators up. So it'll be 1 plus x plus 1 all over the x plus 2. And then here there's nothing to distribute, so you can drop the parentheses and just combine like terms. You get x plus 2 over x plus 2, which, in this case, exactly cancels, right? This is the exact same thing in the numerator and denominator, and that just becomes a 1. Kind of nice. Okay, comma though, don't forget that little exclusion here. X not equal to negative 2, right? So in other words, this does equal just 1 as long as x is not negative 2. Okay, but now that already had common denominators. Let's look at something that doesn't have a common denominator. So for example, right here, okay, our directions are to add or subtract, simplify, and identify any excluded values. So kind of like some of the stuff we did yesterday too. Okay, so looking at our denominators here, we can see that they are not identical, right? This one here is 3x, this one here is x. So can we manipulate these denominators in any way so that we can get them to be the same? Well, the answer is, of course, yes. Okay, what is this denominator missing? Hopefully you said 3, right? It should be a 3x. All right, so what we'll do here is we'll multiply this denominator by 3 over 3. Now, do I need to multiply this denominator by anything? No is the answer, okay? And again, when I ask you guys questions, feel free to pause the video, answer the question in your head first or out loud if you want to sound like a crazy person, and then talking to yourself. Just kidding. Anyway, then combine. Well, sorry, and then start the video up again and see what the answer is. Okay, it's a much better way to interact with these videos than just kind of sitting there passively. It helps you to be a little more active in your own learning and stuff like that. Just a suggestion. Okay, so we'll distribute the 3 to both terms here. So it becomes 6x plus 3 over 3x. Okay, I know it's x times 3, which is the same thing as x times 3, but 3x is the same thing too. So now we can combine our numerators there. Okay, and again we're adding, so it'll be x minus 4 plus, okay, all over 3x. And so we can now just combine, so we get 7x, and then negative 4 and 3 make a minus 1 over 3x. And there's no more simplification we can really do here. Okay, we cannot cancel these x's out because of this minus 1 right here. Okay, this is not x times this whole quantity, it's just x times the 7 there. So these x's cannot cancel like that. What you could do if you wanted to is do like 7x over 3x minus 1 over 3x like that, and then cancel the x's out. That's an option. But again, we want to stop with just a single fraction right here. So we're going to say this is our answer. But you could have done that. We also want to identify any excluded values. So, well, x cannot be equal to 0 here. right? That would be excluded because if x was 0, then the denominator would be 0. Okay. Which technically, well, yeah. Maybe I'll write it like this, excluded values. Okay, like that. Okay. Because we still have this x here in the denominator, so like this original thing here is technically exactly equal to our original problem right here, because both cases still have, 0 creates a problem kind of thing. So we didn't like lose that, problem. Anyway, let's keep going here. All right, so next one. Okay, again, we can see we do not have common denominators. However, they both have an x, right? But one of them is missing something that the other has, right? This denominator here does not have that x plus 1 there. So we're going to fix that by multiplying, and I'll put this in a different color here. Multiply the top and bottom by x plus 1 over x plus 1 for this fraction on the right here. For this fraction right here, we'll have to fix that. Okay? So this fraction stays the same. So we get x squared plus 4x plus 2 still over the x times x plus 1. And now we need to multiply this out, which, yes, requires us to FOIL it out. So it'll be x squared times x squared times 1, 1 times x, 1 times 1, just like that. So x squared times the x is x to the third, x squared times the 1 is x squared, 1 times the x is x, and 1 times the 1 is 1, all over x times x plus 1. Okay, and now we have a common denominator, so we can just combine our numerators together. So we'll end up with x to the third, and then the 2x squareds add together, and then 4x and x makes 5x, and then 2 and 1 makes 3. Put that all over x times x plus 1. And voila, there's our answer. Okay, you can try and factor by grouping here or something like that, but it's not going to simplify any further, so we're kind of done here. The excluded values are x equals 0, or x can equal 0, and x cannot equal -1, right? -1 right here would also make a 0 in our denominator. Okay? All right, let's keep rolling here. Ooh, a subtraction problem. Ooh, okay, this one looks a little bit different, right? So again, we can see don't have common denominators, so we cannot subtract here. But the difference is that this has just a minus 5x, whereas this one doesn't. So can I just like subtract a 5x from the bottom and subtract a 5x from the top? It's doing the same thing to the top and bottom, right? Well, yes and no. Subtracting a 5x in the numerator and denominator is not the same thing as multiplying by 1. When we did our corrections, like here, when we found that common denominator here, or we found the common denominator here, we are not adding 1, we are multiplying by 1, okay? And in fact, that's the only way this is going to really work, right? You'll notice up here, for example, with, the 1/4 and the 1/8 problem, right? I didn't add 4 to the top and bottom to make 5 over 8, right? In fact, that would be wrong. It should be 2/8, not 5 over 8 there. So we can't add to the numerator and denominator to get our common denominators. We have to multiply, and we're multiplying always by 1. So what are we going to multiply by? Oh, wait a minute here. Oh, right, yeah. So this is our original problem right there. So what are we going to multiply by? Well, we could multiply this right-hand side by the whole denominator here, right? So we could multiply by x squared minus 5x over x squared minus 5x, and then multiply this denominator by, well, the other denominator here, so x squared over x squared. But good gracious, that's going to be big numbers, and I think there's a simpler way. So what do we do? Well, so let's start by factoring this denominator over here. Okay, and then let's over here, same thing. Can't really factor it, it's just x squared. But you can see here that these actually do have something in common. They both have one x in common. But what does each one miss? Well, this x right here needs to be an x squared. So what will I do? I'll multiply over here by x over x. And now we'll have an x squared in our denominator here. What's this denominator missing over here? it is missing an x minus 5 that's from over here. So we'll multiply the top and bottom by x minus 5. Like that. So we have to multiply two things here. When we multiply those out, we'll get 2x to the third over, whoops, and there's an x there. It's supposed to be an x. Okay, and so that'll be x squared, x minus 5. And then the numerator here, oh, I got to factorial this all out. So let's see here, it'll be x to the third. So it'll be, x times these three. So x to the third plus 3x squared minus 4x. And then the minus 5 will also have to multiply by all three of those. So that, and that. So minus 5x squared minus 15x plus 20 all over x squared times x minus 5. Okay, and now we're going to subtract these two things, so that minus sign actually distributes. In fact, I'm going to go ahead, I'm just going to change this to add the opposites. And then combine all these like terms here together. So we have a negative x cubed, and the 2x cubed becomes just x cubed. And we have a minus 3x squared, but a plus 5x squared. Minus 3x squared and the plus 5x squared there become plus 2x squared. And the minus 4x, no, it's a plus 4x and a plus 15x. So plus 19x and then minus 20 all over x squared times x minus 5. Okay, and you can try factor by grouping here, but it's not going to factor by grouping, so we'll just kind of leave it right here. And the excluded values are x equals 0 and x equals positive 5. Okay, got one more for us. No, I got two more for us here. I'm gonna go quick with these. Okay, here we go. Same idea here. You can see we don't have a common denominator, but this thing factors. Let's factor it out. Okay, you can see that this denominator is missing that 2 plus x there. So we'd multiply the top and bottom by 2 plus x. Again, because we're really just multiplying by 1 when we do that. We get x squared over 2 minus x, 2 plus x, minus 2 plus x, and the numerator, ooh, that, over 2 minus x times 2 plus x. Okay, and again, we're subtracting here. That subtraction just distributes, so we'll make it add the opposites here. And so we'll get x squared minus x minus 2 if I put it in, standard form there. And then 2 minus x, and then 2 plus x in the denominator. Notice when you add the fractions, the denominators do not get added. I mean, they just stay the same, right? Because you're adding that's your unit kind of thing. So there's our final answer. And I don't think, no, that does factor. Shoot, it's x minus 2 and x plus 1. Okay, like that. And then you'll notice that these are very similar, but they're opposites. If I take a negative 1 out from this, then it becomes 2 minus x, like that. And then those 2 minus x's cancel, and so we're left with negative x plus 1 over 2 plus x. And you can just read that with negative 1 if you want to, or just leave it that way. But it gets x's cannot be 2 or negative 2 there for the excluded values. Okay, last one here. Again, upon first blush, first glance here, these two denominators do not look at all the same. However, factor. Okay, both these quadratics factor, which is why we emphasize factoring so much in the quadratics unit and in the factoring unit. And you can see here that, aha, we do have two things in common. So what's missing? This denominator here is missing another x minus 3. It needs a second one. So we'll multiply the top and bottom by x minus 3. And this denominator here is missing this x minus 8. So we'll multiply the top and bottom by x minus 8. Okay. And so I end up with negative 14, negative 14x when I distribute here. Plus, let's see here, 2842 over, and I'm just going to leave this unmul. In fact, I'm going to go ahead and say it's x minus 3 squared times x minus 8, because those x minus 3 times x minus 3 will make it x minus 3 squared. And then again, distribute the 9. So 9x minus 72 over x minus 3 squared times x minus 8. And then just combine your like terms here. And we're adding, so it's very easy to do here with that. So negative 14 and 9 makes negative 5x. 42 minus 72 is negative 30 over x minus 3 squared times x minus 8. And voila. And yeah, you could factor the negative 5 out if you really want to. It's not necessary there, because again, it doesn't really simplify any further. So you can, it's your choice how you want to leave it, but that's okay too. Okay, excluded values here would be x equals 3 and x equals 8. Well, it's a good thing that I did not do the multiplication division, because I went long even now. So anyway, hope that helps. Again, if you have questions, please leave them in the comments on the updates page. Thanks, guys.